Math is clean, math's easy when you're doing math with Miss Lee.
This is problem number 14 from page 4 in packet 1, unit 4. First, I need to find the amplitude and the period. So in this equation, a equals 3 and b equals pi. Amplitude is the absolute value of a, which is 3, and the period is 2 pi divided by b, which in this case is 2. So now to make my graph, I'm going to use two different methods to find points in one cycle. The first method will be transformations, just like we did in the first unit this year. So I'm going to start by writing down the x and y coordinates of one cycle of y equals sine of x. And the period is 2 pi. And this will just be something you'll eventually memorize. So then from here, the equation is going to change both the x's and the y's because I have constants that are different from y equals sine x, both inside the parentheses and outside the parentheses. So inside the parentheses, the x is being multiplied by pi. That number affects the x inversely, so I'm actually going to divide the x coordinates by pi. So dividing 0 by pi remains 0. Pi over 2 divided by pi is 1/2. Pi divided by pi is 1. And then I have 3/2 and 2. Those are my new x coordinates for one cycle of the graph. The y affects the graph the way it seems like it would. So we're going to multiply the y's from the first table by 3. So the zeros will stay the same, and that will make the 1 a 3, and the negative 1 will become a negative 3. So then when I graph, usually what I do is I draw myself some horizontal lines at the max and min values so that I can just kind of wave the graph in between those. And then I will show my zeros, and in between those I'm hitting the maximum and the minimum. So here's my 0, 0, 1/2, 3, 1, 0, 3/2, negative 3, and 2, 0. And then there's my curve from there. Now to form my second cycle, I'm just going to draw exactly the same shape, and the period of the graph is 2, which I found earlier. So that means that these key points repeat every 2 units. So this is 2 units past the 1/2, comma 3, so this is 2.5, 3. This point is 2 units past the 1, 0, so it must be 3, 0. This point is 2 units past the 3/2, negative 3, so it must be, let's see, 2 plus 1.5 is 3.5, negative 3. And then this is 2 units past the 2, 0, which was key point number 5, so that's 4, 0. Now what I'll do is I will repeat the same process, but I'm going to use averaging to find the values in my table instead of what I did before. So I'm going to recycle the amplitude and period from what I had earlier, and using the averaging method, I am not going to use that initial table. What I'll do instead is to find the first key point, I'm going to set what was in the parentheses in my equation equal to 0, which is my normal starting x value, and solve that for x. So dividing both sides by pi, I get x equals 0. So x equals 0 is the first key point. Then I'll set the same expression equal to 2 pi, which is the original fifth key point x value on the untransformed graph, and then dividing both sides of that by pi gives me x equals 2. So x equals 2 is where the fifth key point lands. So then to find the third key point, I'm going to average 0 and 2 together by adding them and dividing by 2, and that gives me 1. So 1 is the x value of the third key point. To find the second key point, I'll add the first and third key points, and divide by 2. So that tells me they're at 1/2. And then to find the fourth key point, I'll add the 1 and the 2 and divide by 2. And that gives me 3/2. So that's the averaging method. Then I will use the amplitude to help me find the y values. So I know based on the shape of a positive sine graph that it's going to hit the middle y value at the first, third, and fifth key points. So I filled in zeros there. It hits the maximum at the second key point, so that's going to be a 3 because of the amplitude now. And it hits the minimum at the fourth key point, so that's going to be a -3. And then I would graph the exact same way I just did before and add the period of 2 to find the points for the next cycle.